What is up, YouTube? It is another JavaScript with Joe. We are on day 17. Come learn JavaScript. If you're watching, let me know in the chat. Are you a beginner? Have you done much JavaScript before? Have you seen Advent of Code? Speaking of Advent of Code, here's a link. So this is where I'm getting all these programming challenges from. They are quite hard. I don't really recommend them if you're a beginner, but they're quite fun otherwise. Hello, Eureka. Welcome. Let me know what your level's at, and I'll try and pitch it towards you a little bit better. But we're going to be doing day 17 today, as we've been doing one every Wednesday at 4 p.m. Every week of this year, pretty much. And they're all available on this YouTube channel if you're watching it on YouTube. This is today's problem, but I'll get into that in a little second. I'm using a website called Replit.com. So JavaScript is a bit of an exception, where it's quite easy to find somewhere where you can write JavaScript. You can do it in most browsers, but a lot of languages, you can't just write lines of code and get them to run immediately like this. And that's where Replit is quite handy. It's quite a good way to sort of get into any programming languages. But I find it particularly useful for JavaScript to host all the code. I can run stuff on this bit in the right-hand side. So this is something called a REPL. Hi, Mafalda. I can see you're a beginner at JavaScript, so I'll try and make things a bit easier. Though I will say that the challenges can be quite difficult. So I'll try and keep it basic, but it'll probably ramp up quite quickly. So to start with, I've made this REPL where you can put a text file and you can write JavaScript in here. When you press this play button, that JavaScript will run over in this area on the right-hand side, and you can access things from that. So this variable input can be accessed there now, but other variables that don't exist won't be accessible. You can also, I guess I should cover, this is over here what's called a REPL, R-E-P-L, and that stands for read, evaluate, print loop. And what this is just sort of a way to run lines of code without needing to read in files. So if you wanted to, you could write something like 2 plus 2. That will be read by the REPL, 2 plus 2. It'll evaluate what that means. So it'll say, okay, we've got these numbers. We're using the plus operator on them. And then it'll print the output. So you can see it's sort of giving the outline of what the output will be. But if you press enter, you'll actually get that output for. And then the loop, we just do it all over and over again. So it just goes read, evaluate, print, read, evaluate, print, read, evaluate, print. So that's what we're seeing over here. So you can, if you want to, start writing code over here. So you could say something like my variable equals 2 plus 2. And then you can access that variable later. So if we call my variable, we'll get that 4 back. We can even add numbers to that 4. We can do all sorts of maths. We can take away numbers. We can divide by numbers. So 4 divided by 4 will give us 1. You might notice we use a slash there that's a bit weird, but that's sort of quite normal in programming languages. And we can multiply, usually using an asterisk. My variable times 4 gives us that 16. So that's a first variable, though my variable is a pretty terrible name. In fact, I didn't even write valid code there. You should use something like either the var keyword, let, or const. The differences there being that sort of var is older. So var, you do something like var my age equals 27, and that will declare a variable called my age, which you can access later with that number. You could use let, which is sort of a newer syntax in JavaScript. So we have a separation between let and const. So let values can be redefined, whereas const variables can't. So if you said const, I don't know, number of eyes, hopefully my number of eyes will stay the same throughout my life. So now if I access that, still 2. If I tried to change that, it won't let me. So we can use that for sort of global constant values, like the value of pi, or mathematical constants, or things that will never change in your program. And it offers you a little bit of protection there. So yeah, you'll use a keyword like var, you use a variable name. Equals is an assignment operator, so a bit different to in maths, you could say 2 plus 2 equals 4. But really that equals sign is more like an arrow, so we're sort of putting a value into our variable. So that's called assignment. And we can call variable names whatever we want as long as it's not a protected word within the language. So variable name doesn't really make much sense. That's why before I use something like my age or number of eyes. The idea being that when we store stuff in variables, they need to be useful to us later, and it's also an opportunity to write something that makes a bit more sense for us anyway. Right, so that should cover us getting started. I'll try to introduce anything extra, but you can see we've got a variable here called fs, which is requiring a package called file system. I wouldn't worry about that for now, but that's just so we can import this other file into this file. I'm defining the input as just reading everything from that file. So this will be a useful pattern for later. Again, if you're a beginner, you probably don't want to set this up yourself, so you could probably just copy this to get the readings working. But anyway, let's look at the challenge. So I'll link it again just in case it isn't there if anyone joined later. So day 17, trick shot. You finally decode the elves message. Hi. The message says you continue... Oh, hi, the message says. You continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the x and y values. For example, an initial xy velocity like 0, 10 would fire the probe straight up, while an initial velocity like 10, minus 1 would fire the probe forward at a slight downward angle. The probe's xy position starts at 0, 0, then will follow some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's x position increases by its x velocity. The probe's y position increases by its y velocity. Due to drag, the probe's x velocity changes by 1 towards the value of 0. That is, it decreases by 1 if it is greater than 0, increases by 1 if it's less than 0, or does not change if it is already 0, and due to gravity, the probe's velocity decreases by 1. Y velocity decreases by 1. Yeah, okay. Yes, okay. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. The submarine computer has calculated the target area, which will be my puzzle input. So if you do choose to sign up for this site, everyone should get a sort of different puzzle input. Wow, this looks like a mess already. Right. So this is my puzzle input, but yours will be slightly different. You don't really need to put that in there, but you can. So we've got an example one, target area, x is 20 to 30, and y is minus 10 to minus 5. This target area means that you need to find an initial xy velocity such that after any step the probe's x position is at least 20 and at most 30, and the probe's y position is at least minus 10 and at most minus 5, right? So this is sort of our end point. Given this target area, one initial velocity that causes the probe to be within the target area after any step is 7, 2. I like this visualization. I don't know if I'm going to do that. In this diagram, S, well, I guess we need to explore like a bunch of different targets, different velocities. In this diagram, S is the probe's initial position, the x coordinate increases to the right, and the y coordinate increases upwards. In the bottom right, positions that are within the target area are shown as t. After each step, until the target area is reached, the position of the probe is marked with a hashtag. The bottom right hashtag is both a position the probe reaches and a position in the target area. Another initial velocity that causes the probe to be within the target area after any step is 6, 3. Wow. Another one is 9, 0. One initial velocity that doesn't cause the probe to be within the target area is 17, minus 4. The probe appears to pass through the target area but is never within it after any step. It continues down and to the right. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? In the above example, using an initial velocity of 6, 9 is the best you can do, causing the probe to reach a maximum position of 45. Any higher causes the probe to overshoot. Find the initial velocity that causes the probe to reach the highest y and still be within the target area. What's the highest y position it reaches? Okay. So my first thought is, should we even try and do a visualization like this, or can we just get away with skipping it? I might try and skip it, just because I think we could like log out these values and be okay, but we'll see. So let's start with this target area rather than our larger complicated target area. So we need something that's going to process this into a target area. Process the input. We need something that's going to sort of increment steps. We need something that's going to check if in range. I think that's a good start point. So as I said, I've already left this little bit of code that's been quite useful from the previous weeks. So that will just read in that file. You could if you want. I mean, in this case, since you don't really need that, you could just take this as a chance to store this in a variable. So we could say var input equals that, and you can comment that out altogether. You don't actually need that this week. So same thing, we now have an input variable, and this is actually a good example of a const, right, as well, because that's never going to change while we're running our code. So I can access the input over there. Next thing I need to do is split it up into the x and y coordinates. So I could probably just try and slice the string to get rid of this target area. So that's a first function we can use. So there's one called slice, and that takes a sort of a start and an end position. Oh, I'm gonna sneeze. Sorry. Right, so you can see there, if I put 0 and 10, it's given us target R. So what this is doing is sort of getting the position of that first character and getting the position of the last character and slicing that bit of the string. So it looks like those numbers aren't quite right, but we could just sort of explore up to get to it. So it looks like 0 to 13 gets the opposite of what we want. So we'd probably want something like 13 to, I suppose, the rest of the string. I think we can just do that. So if we just give it one value, it'll cut from 13 upwards, which gives us the rest of the string. So it might be useful to store that as well. So const, I don't know, input nums equals input.slice 13. So that's good, but it's still something we haven't actually talked about yet, is the types used. So if we put type of input nums, we'll see it's a string. So what this means is that JavaScript has decided this is a string, and that's actually why it has quotes around it, which makes sense because anything put in this file could have been a string, and there isn't really another type that would make sense for this. What that actually means is we could have something like cat plus dog, and this wouldn't make any sense in English, right? Well, you know, we wouldn't describe words like this, so we definitely wouldn't expect this to work in maths, but in programming, that plus has a sort of a function that we would call concatenation. So it kind of makes sense if you say, you know, I want cat plus dog, you just put them on next to each other, and that's what we get in JavaScript. Different types will have different functions associated with them. So I believe we have stuff like, is it to uppercase, that will uppercase the whole word. So there's a bunch of useful stuff that wouldn't make sense for numbers, but does make sense for strings. And one of those was slice. You've already seen that actually. So we couldn't call slice on a number. Yes, we can't. Good. So another function that's quite useful is called split. So we could say catdog.split. In fact, I haven't even spoken about functions. That's what this dot notation is for. So I'm calling the functions on the object string, and you learn that these exist over time, or you write them yourself, and other people will point out what is a better use of your time rather than rewriting functions that already exist in JavaScript. So if I do split, I can pass a parameter. So that's anything that goes in those functions is called a parameter. So that was parameter 1, parameter 2. They usually have names as well. We might see that in a little bit if we start running some functions. And if I say I want to split on t's, I'll get this list. So another type called an array or a list, denoted by these square brackets, of objects that are split on that t. So we've got the CA from before the t and the dog after. And the reason I'm bringing this up is because we want to split this into an x and y. And so you can have a try yourselves. But if you do this dot split, you need quotes around any string and have a think of what we want to split this string on in order to split the x and y parts. So you could do the space, you could do the comma, but I'm going to do both because I don't need that comma or that space. So something like that will probably work. So there we go, we've got them separate. I'm going to need this again to split on those dots anyway. So const, I don't know, ranges equals input dot split, input nums dot split, comma space. So now we should have that object. Again, it's not quite there. Really, we need to go a little bit further. Maybe break it down. I mean, what I really want from here is probably an object of like 20, 30 for x and minus 10, 5 for y. So I guess I could do const x range equals ranges 0. So this will get the first value. Ranges 0. So again, another new notation here if you're familiar with lists and arrays. That's not really enough. I want to get rid of the first two characters and I want to split on the negative. So this is everything we've seen before already. We just need to run that slice function once. We need to use that split function once. And we can actually chain them all after each other. So we can do ranges 0 dot slice. I just want to get rid of the first two characters, so I can just put 2 in. Then I can call dot split, and I want to split on those 2 dots. There we go, 20 and 30. It's a good line. Can I copy that? No. Right, so dot slice to dot split, like that. And I can do the exact same thing for x for the y range, but I need to change just one thing. So have a little look. Though in this case, all we have to do is change this 0 to a 1, so that's accessing the second item of our list instead of the first item. X range, y range. So there we go, we've got our strings. They're not numbers yet, and that looks alright though. It should be minus 10 and minus 5. So that's looking good. We could simplify this a little bit more. We could chain those splits here again. And that's exactly the same, just saves us. Oh, ranges is not defined because it saves us a little bit of just some lines of code basically. So y range, x range, cool. Now they are strings when they shouldn't be, but that might not be a problem. So next we need to define our starting point, which we saw way up here was always 0, 0. So we could say something like const start position equals 0, 0. And I guess we could, for now, let's just say launch velocity equals 0, 0. And let's set that to be 7, 2. And this is one that should end somewhere where we're expecting it. 7, 2. Okay, so start position 0, 0, makes sense. Launch velocity 7, 2, x range, y range. Cool, so everything looks good there. We could actually write some code that does exactly that for us. So we can print out anything with this console.log function. So log is a function of a console object, and then we're passing in start position as our parameter to be logged out. So this just looks like that, just prints it out. We could do that for everything. So let's use this, and it'll sort of be a quick diagnostic tool each time we run. So there's everything. There's no context there, so we have to kind of look at this code to see what's happening there, which doesn't really make sense, but there is something you can do in JavaScript now. So you can put sort of a handy string in here, and then that string will be logged out alongside what you're logging. So that's a good pattern to use as well. So put those two there, this here, y range here. And that doesn't have to be the same as the name of the variable. So that's just the first parameter to the function will be a string that's printed out. So that's quite useful. Next, we want to increment some steps. So there's a lot of additional requirements here for gravity, for drag, which I'm going to ignore for a second. Let's just see if I can... Oh, let's wrap this up in a function as well, actually. But we'll see if we can do that. So we've not written any functions ourselves yet. So all the functions we've seen so far are slice, split, and log. But we can actually write our own. So let's write a quick one that does all this printing for us. So we can do const print, I don't know, print stats equals round brackets and arrow, like that. This is called an arrow function. So this is where we put our parameters. This is where we put the body that we're going to run. And we're not actually returning anything, but in a lot of functions you'll return something with the return keyword, but we're not doing that here because there's just logs going on. So now if I call print stats, in fact, if I don't call that, you'll see that nothing happens. So this has now been put inside a function. In order to use that function, we have to call it. So we call print stats with round brackets. So we just put print stats, that's the reference to our function. It doesn't do anything. I can even type it here. And it just prints out the function. You have to put the round brackets to call it, or you have to put any parameters in here that we asked for. So I could put in a number here, and then we would have to put in that number there, but that's not really necessary for now. So I'll call that print stats, and every time we run it, we should just get those stats at the top. We'll use a similar pattern once we do increment these steps, actually. Okay, so up next, let's just see if we can increment the value. So we should, all we need to do is add this number to this number, add this number to this number. So running a step, and we probably want to do something like let new position equal start position. In fact, we don't want start position really, we want old position. Start position 0 plus launch velocity 0, comma, and the same thing again, but for the Y position 1, 1. Let's tidy that up a little bit just to make it more readable. Right, so our new position is 7, 2. That makes sense because we were at 0, 0. Might be worth changing some of these values just to test that. So if I put -1 here and a +8, we should still get 7, 2. Yep, cool. So I guess what we really want to do is iterate over this a few times. So we could use a for loop for that. We could use a while loop. The condition of the while loop would probably be if it's in the range, but we don't really have that yet. So let's just write a for loop that runs this 3 times and sort of use that to refactor. So for, we need to declare a step counter. So that step counter start at 0. Then we want to run until the step counter is 5, so it's run 5 times, and then we want to implement the step counter. And this is just a pattern that you'll get very used to writing. So I'll just write in here step count, step counter. So exactly the same pattern we were using up here. And there you go, we can see it ran 0, 1, 2, 3, 4. Okay, so what we really want to do is run this each time we're in the for loop. So we probably need a notion of we could just overwrite the new position with the old one. So let's bring this in here. I'm going to say let new position equal start position. Then we're going to overwrite the new position with its current value. And then within this, instead of just logging the step counter, we also want to log the new position. Oh, can't access new position before initialization because I've declared it twice, I think. There we go. So we can see we started at 0, 0. We're moving 7, 2. We've gone 7, 2, 14, 2, 21, 6, 28, 8, and 35, 10. So that's gone in the right order. There's no implementation of drag, no implementation of gravity, but that's okay. We'll do that now. So let's do gravity first because that one sounds a bit easier. So before this, do we implement gravity after each one? So it goes up to, so actually implementing gravity before the next turn, I think. So we do want to update this first. Is that correct for the 7 as well? 1, 2, 3, 4, 5, 6, 7. Yeah, okay. So we're updating this for the next time. Ooh. So we could have like a drag modifier, or we could actually just update the velocity with a new velocity. So let's do interesting. I guess we can do that here. Let velocity equal start velocity, or launch velocity. And then here I want to do velocity equals velocity 0. That question, hi, when do we use the +2 overloads? I don't know what that means. You might have to rephrase that, Eureka. Are there overloads somewhere in this? I'm not sure, you have to clarify a bit there, but I'll answer it in a sec. Right, so velocity equals, I'll have to do something similar to this. So velocity x will stay the same. So velocity 0 is just equal to velocity 0. Velocity 1 will equal, don't think I need that. Velocity 1 will be velocity 1 minus 1. That should give us, oh, no it doesn't. Because I'm still using the launch velocity here, that's why. Cool, so there we go, we can see on the y-axis now, we're going up a little bit, and then we're slowing down and we're coming down. So we do have that arch, it should be 2, 3, 3, 2, 0. We've got 1, 2, 3, 3, 2, 0. So that looks good. Let's increase the number of times our for loop runs because we need 2 more of them. So I'll do that with this step counter here. So that is supposed to now be in our target range because it's within -10 and -5, though it's not within 20 and 30, but we haven't implemented drag yet, so that's not too surprising. So we could actually implement the drag in there. So let's do a little calculate drag. And this is a good opportunity to write our first if statements too. So we can say if velocity, and again this is something I haven't seen before, so we have the reserved word if, we write a condition in here, and then we write what happens if that condition is in here is true. So we could say if it's raining, then we take an umbrella or something like that. Say if is raining, then we would take an umbrella. So in this case, we want to say if velocity is greater than 0, then it's moving right, so the drag should slow it down to the left. So that's when we want to say const. Well, let's calculate. Let drag equals 0. If velocity is greater than 0, then drag should equal -1. Else, if velocity is less than 0, the drag should be the other way, though I don't think that would ever happen with our inputs unless we started launching from other locations, so it shouldn't really be a problem. But let's put it in anyway, drag equals +1, and then otherwise drag is 0. Then in here we can just add that drag in, and it doesn't look like it's slowed down, so I'm guessing it's always going in here because I'm accessing all of velocity, and velocity is of this shape, right? So that can't be compared really. I don't know what that will do. 0 is greater than 0. False. I mean, it doesn't really make much sense, but there's 2 different things happening there. So this needs to be velocity 0 for our x component. This needs to be velocity 0 for our x component too. There we go, 28 and 7, which is between 20 and 30 and between -10 and +5, so that's looking normal. We could probably benefit from using some more variables here. So why don't we say, I think I can do velocity x, comma, velocity y here, will that work? Velocity x, cool. Is that because it errored? Oh, maybe I can't do that. Cool, okay. So we've got drag, we've got gravity. At this point, we've basically got what we need. We just need to check. We need a little function that would check if it's in range. I think we should probably move this drag calculation outside as well, so we can practice writing another function. So const calculate drag x. Let's call that lowercase x equals x. Arrow here. This time we will return something. So let drag equal 0. We can then say if, or we can copy this. Since drag is already 0 unless we go into an else statement, we can do this as well. Then return drag, calculate drag, can replace this. In fact, we don't need that at all. Just put it in here, calculate drag, velocity 0. It should all be the same. And it looks like it is. I didn't explain this before, but if you put 2 slashes, you can write a comment that doesn't break the code as well. So this is just for the programmer, basically. Drag and gravity. Ooh. Oh dear. I jumped here up top. Calculate new position. Increment over steps. And log step data. Cool. So next we need to check if we're in the range and get away from this for loop. To do, should stop when in range. We've got our drag function. We've got our, don't need that, running a step. We could probably move this down to the bottom, so we're actually running our code at the bottom. We can move these variables we're not using to the top, so these are sort of all our useful variables at the top. In fact, I'll put this up here. The input's processed, so that's fine. And yes, okay, now what was I doing? We need to calculate if we're in the correct position. So let's call it check in range. So const is in range. That needs our x range, y range. Oops. So those are our 2 parameter names. Arrow here, and this is probably going to return a true or false. That's called a Boolean value. We've not actually seen those yet. So type of true. It's called a Boolean. So these are types that you've probably never heard of this. You've probably heard of strings and numbers and integers and stuff, but Boolean is quite unique to computational thinking, I would say. And it just refers to true or false. So all those conditions inside the if statements were Booleans, for example. Right. We also need our current position, right? So current position. I'll just call it pos. Do we have the position? Position is our new position variable, which is here. Okay, that's fine. So in, let's say, let's in x range equal so we can do x range 0. 0 is less than pos 0 is less than x range 1. Then exactly the same for the y range. Oops, y. And then we just want to return if it is both in the x range and in the y range. So this double ampersand just means and. So if we were going to say, I want to do this when it's raining and when it's windy, that condition would only be true when they both are. So if it was rainy but not windy, I might go outside still, but if it's rainy and windy, we definitely wouldn't. So that's called Boolean comparison if you want to Google that, but I won't go into that too much. So I think we now have this function is in range that should take range, say 0 to 10, another range, say 20 to 30, and our current position, let's say it's 5 and 27, which should be in range. That should give us true. Ooh. Oh, that's so annoying. Is in range. So 0, 5, 10, 20, 3, 17. That should be true. And it is. If I change the position to be way outside, just in the x-axis, still true. So it's not right. Does that happen if I change just... Oh, 3 was... No, 3 was in range. Let's do it again. Yeah, so it's always returning true. So I guess... Is it possible that this is not valid JavaScript? If this one is 13. True. Is that because the first statement is evaluating to true? And then true is less than 10. Yeah, okay. I thought I could do that. I guess I could just split it again, so I could say that is that and that. Oh, and I'm passing the wrong position in here as well, actually. Was that what was wrong? Was that what was wrong? Is in range 0, 5, 10, 20, 3, 15 will be true. So I should be able to break this by going to 6. No, see, it's definitely... It was wrong for a few reasons. I think it needs that addition I had. So it needs to be pos 0 and the other one, and the same here. Pos 1. Pos 1 is in range. Let's just start using our actual ranges. X range, Y range, start position. Ooh. Post. Is in range, X range, Y range, 0, 10, 12 is false, and our X range as set up here is 20 to 30, minus 10 to minus 5. So let's fix one of them. So if this is 25, still false. This is minus 7, it should still be false, but if it's both minus 7 and 25, it's true. Cool. So that's now working. It's a little bit long, but it'll do. So in here we can say, I guess, let is in, so I call it is in range. Let in range equal is in range, X range, Y range, new position, console.log is in range, comma, in range. Okay, so now we should be seeing, we see all these falses now. So after the, whoa, there's a lot of step counts going on. Let's clear that, try it again. Yes, okay, so step 0, we've moved to 7.2, we're not in range. Step 1, we're at 13.3, so we move 6 in this direction and plus 1 in this direction, so that looks good. And you do see that it ends on is in range true there. So what we can do now is we can forget about this for loop, so we don't need a step counter anymore. Where did that step counter come from? In there. Yeah. So we can say this in range, so let in range equal that. And we can say while not in range, So another thing we've not seen before, this exclamation mark just means not, in the same way this double ampersand means and. So while not in range, we're going to run all this code, so we can get rid of that all of this. And now it should run exactly the same. Oops. Can't be reliant on the step counter anymore. Cool. So now it runs forever, which is a bit weird because we're not recalculating in range. So I need to run this again at the end of every iteration, which is kind of what we're doing here. So that will update it. Now it should only run 7 times, hopefully. There we go. So it ends once it's in this position. We can see here is in range. Why is it logging the extra? Print stats should be happening before this while. Stops when it's in range now. Looks good to me. Yes, cool. We also need the highest point it reached, though that's not. Let's figure that out. Okay, so let's say let highest point equal start position 1. So highest point at the moment is 0. And then in here we need to say if new position 1 is greater than highest point, then we say highest point is equal to new position 1. Oh, and I need to log out highest position so far. Highest position so far. This, and we should get 3. There we go. So we see highest position so far was 2, then 3, and then just stayed at 3. We saw already that was the peak. So we should be done now. So I can try these other ones. So 6, 3, we should get highest position of 1, 2, 3, 4, 5, 6. And I can just change this here with our launch velocity. So there we go, highest position 6. 21 and minus 9 is within that range. 90. Oh, I've just realized that there'll be points where we actually need to end our while loop. Oh no. Is that proving my point there? That one should end here. So something's a bit off. 1, 2, 3, 4. Wow, it's very quick. Too quick to stop. That one should be working, so something's going a bit wrong there. Let's bring back the step counter to diagnose that. Our step count is less than 10. I've got to increment step count down here. Step count equals step count plus 1. And let's go on that. So 20 and 30. I know what it is already. So this one, because it's right on the edge, between this one should be our valid position. But our check up here was only checking if it was less than or less than, when it should be less than or equal to, and it should be greater than or equal to. So I think if I do all that, the while loop should go back to working. So there we go, true in range, as I said. So I just need to pop all that back in here. So this should be in range. Don't need the steps anymore. Don't need the steps anymore. Oh, no, it's not running at all, because it should be when not in range. There we go. Right, now we have our first case where it shouldn't land. So for our code so far, this will just probably run forever because we haven't got any other termination. So we need to define something that means it ends. So looking at this, we could probably safely say that it's out of range if it's gone beyond these bounds, right? If it's already gone to the right of the target zone or below the target zone, we know we're never coming back. So we could add something to is in range, so that doesn't really make sense. So let's do const is out of range equals x range, y range. Probably do x limit, y limit, and position arrow. Then we can do let out of x range equal x limit is greater than position 0 is greater than x limit, and we need to do the same for a y range, so we can say out of y range position 1 should be greater than y limit, and then we can return if either of these are true. So if out of x range, or, and I didn't show this before, but these two bars, this is or, out of y range. So then we want to end if it's, so while we're not in range and not out of range. While we're not in range, keep going. While we're not out of range, keep going. Yes, okay. Let out of range equal is out of range x range 1. Ooh, yes, and y range 1, and our position, this needs a lowercase o, and we need to update this where we update the other range. Oh, pos is not defined. So looking at this, says on line 51. So I know here this position is not defined because it should be new position. Out of range, but out of range is spelt wrong. Off at range. Here we go. Out of range. So it's terminating immediately, so this isn't right. So while not out of range, and it should not be out of range yet, so that should be getting 30 and minus, oh, minus 10 is the bigger one. Is it always going to be like that? Okay, it is for the y, so that just needs to be y0, I think. Nope. So minus 10, 30, new position would be 0, 0 at this point. So is 0 greater than 20? Yes, it is. Sorry, no, it's not. But is 0 greater than minus 10? Yes, it is. So that would be false. This would be true. Wait, so all I've done here is I've mixed up. Obviously for right, out of range needs to be lower, but for left, out of range needs to also be lower. So if the position, no, sorry, for x, we're out of range when we've gone past the x limit, which is correct, but for y, it's when we're less than the x limit. Y is less than the y limit even. Ooh. Okay, so it ended immediately, but now it's complaining about position not being defined at line 72, which again, I didn't pass the right thing in. Cool. So there we go. We never reach is in range. So we went out of range here when we hit 33 and 9. Minus 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Didn't even calculate the next one. Okay. So I guess now we kind of need to like span across a range of potential solutions. So naively, we could just say, let's try everything from 0 to 10 and 0 to 10 for both of them, which might cover us for this. I think, what did they say? The highest was 6.9. So it would cover us for this, spanning across all these options. And it would happen to catch the best one, but I don't know if there's probably something more clever we can do, right? Where you could launch it really high. I guess your steps could never be... You could obviously never be wider than this target zone, and you could never be larger than the target zone's height in your launch velocity, perhaps. But we could just be really naive and put like really big ranges on what we're going to do. So we could say like double the target area, we'd probably catch it. That would be pretty tricky. Thank you, Eureka. That's very kind of you. Thanks for coming. Like I say, we're here every Wednesday, 4 p.m. And there are like 17 other videos of me doing this. Though I do, if people don't show up, I probably am not as beginner friendly. So do pop along. Right, let's see if we can figure out how to try a bunch of different starting positions. So the highest point needs to sort of transcend this range, but we can say for let x start equals 0. Let's go up to x start. Let's go up to 11. In fact, we don't want to start at 0, so it's not a start, it's an x velocity, and x velocity plus plus. Then I'm going to do the exact same for loop, so you can nest these for loops inside each other. But this time we're going to talk about y velocity. Then I want everything, I guess this needs to be inside to start our loops. But I'm going to keep that highest point outside so that we can calculate it across various runs. So I'm going to grab this whole while loop. We've only got 2 minutes left as well. I didn't say at the start today, but I only spend an hour on each one, so it's very unlikely. Probably finish about a third of them, but for the last few weeks it's been really, really hard to finish any of them. Right, so that should be one more in. Indent all this a little bit more. And will it work? Okay. We're still using the original positions, so I need to grab all the launch velocity. We can't be using that. So these need to be defined inside our for loop each time. So new positions always set back to the start position. That's fine. The velocity should be the x velocity and the y velocity from our loop. That might work. We've got 1 minute left. Let's see. Can I access new position before its initialization? Did I? where is new position being accessed? Line 52 here. So these just need to be slightly higher than the range checks, which makes sense. Velocity is not defined, line 19. Ooh. Velocity. So now every time I call calculate drag, I also need to be passing it velocity. Do I? Velocity 0. Loss. Ooh. Oh, I'm not sure about that. Oh, here we go. Okay. Right, so we got the highest position so far as 55, which isn't good, because it should be 45, I believe. So something is off there. I don't know if I'll be able to find the point where it broke though. Okay. I can't even see the scroll bar. Why did it start at 55? Stop. No. It's getting too quick for me. It's a bit annoying. So we seem to be off by 10, but that could just be something we're trying, or one extra iteration than we're expecting. Or even one of those edge cases, right, where we're doing less than or equal to something. So we're pretty close, but we didn't manage to submit even the first half, and I didn't explain that after you submit this, you get a second half to the challenge that normally punishes you. I imagine for this, they probably moved the start position around, which I think we built quite well for, to be honest, because we kept the start position separate. I guess our out of ranges would probably have to be flipped depending on whether we started to the left or right or above or below the limits, and so that probably be punished for that, but we'll see. But anyway, that's everything. If you do have any questions, I'll leave the stream on for a couple of minutes, so feel free to write anything you do need. But otherwise, thank you very much and see you next week. Bye-bye.